So we've said that we have combustion, we have hydrogenation, we have halogenation, we have hydrohalogenation, we have oxidation, where we have to use these oxidizing agents like potassium manganate 7, potassium bicarbonate 6, and sulfuric acid. So these are oxidizing agents that can actually employ this aspect of oxidation. So I want you to use an example like ethene with the hydrohalogenation, so that you can be able to see what you can get if you have to write a chemical reaction involving those two. Use ethene and HCl.
This is hydrohalogenation.
Yes.
It's not O.
It is an alkyl.
Yeah. So how is it hydrohalogenation?
You know you have written C2H6, which is an alkane. Yeah, it is correct. It is correct. Very good. So if I have to maybe explain this in detail, we have two cases whereby someone can ask you about let's give this practical example, isn't it? And the example can be, now I want to see, if I say CH4, then I say plus Cl2, isn't it?
Yeah.
I say that this requires UV light from the sun. Okay? So in the presence of the UV light from the sun, we can have CH3
plus HCl.
plus HCl, isn't it? So I can do this. Plus Cl, isn't it? Then you're going to form. What happens? The hydrogen escapes, isn't it? On escaping, it comes to this other end. Okay? This part comes to occupy this position, isn't it? I know very well there's a shared pair of electrons here, isn't it? There's as well a shared pair of electrons at this point, isn't it?
Yeah.
What type of reaction is this? It's a substitution reaction, isn't it?
Yeah.
And it's called radical what?
Substitution.
Among alkanes. Alkanes. Yes. We are still working on the first one. There's something I want to explain. Now, in this case, they may ask you in examination, differentiate between homolytic reaction and heterolytic reaction. And that is where the problem comes in. If they say homolytic reaction, this is a type of reaction whereby the covalent bond breaks. You see, after the covalent bond has broken, isn't it? The living species, isn't it, lives with its own electron. You get the point?
Yeah.
Isn't it? Then the bond again breaks here covalently, isn't it? The living species also comes with its own electron. You get the point? So that I have at the end of the day C, H, H, H. Then C, this one left with its own electron. Okay? Then this one remains with its own electron. You get the point? So when this one comes, the incoming species to actually replace or actually occupy the position initially occupied by the living species comes with its own electron from the shared pair to form another covalent bond. This is the case here, isn't it? So the living species, isn't it, has left with its own electron, isn't it? The remaining atom from the second covalent bond that gets broken also joins this other living species with its own electron from the shared pair. So a type of reaction where a covalent bond gets broken, isn't it? And the atoms between the two covalent bonds equally have to keep an electron or electrons onto themselves, isn't it? Is called homolytic. Homo means the same. That means they end up giving an equal number of electrons to themselves, isn't it? After the bond gets broke, like if there's a divorce case and people have to separate, they will say 50-50. That one becomes homolytic. You see? So that means a covalent bond gets broken during a reaction, isn't it? And each of the atoms forming that covalent bond which has been broken will equally keep a pair of, or will actually be able to keep an electron onto themselves from the shared pair. You see? So this is where a covalent bond is broken and each atom that had initially formed that covalent bond will keep an electron from the shared pair onto themselves. You see? That becomes what? Homolytic. You see? So that in this case, it's not that one species goes with everything. They equally have to keep an electron from the shared pair onto themselves. That becomes what we call homolytic reaction. So they can ask you, where does homolytic reactions occur? Homolytic reactions occur among radical substitution in alkanes. You see, where when the covalent bond breaks, isn't it? The shared pair of electrons will get equally distributed among the atoms forming the what? The bond. That's what the. So this is when a covalent bond breaks and each atom keeps one electron from the shared pair of electrons in the bond. You see? So we'll end up forming what you call free radicals, isn't it? If you look at heterolytic, how can you use an example of an electrophile addition reaction in alkenes to show heterolytic?
Alkenes.
Yes.
CH2 plus CH2 plus Cl2.
CH2 plus Cl2. CH2 plus Cl2.
C2H4 plus Cl2.
C2H4 plus Cl2. How will that show heterolytic reaction? Maybe you can try. How will it show the heterolytic reaction? I've said under homolytic reaction, a covalent bond gets broken, isn't it? Such that the shared pair of electrons, isn't it, will equally get shared between the two atoms forming that covalent bond which has been broken.
Each atom
picks an electron from the shared pair.
And the other one, only one atom.
And the other only one atom will pick all those electrons. So you can try to show and see whether it can be able to give you the answer.
Plus Cl2 plus HCl.
Yes.